Okay, thanks very much. I'm a bit of a walker when I give talks like this, and I've been told that I've got to stand here because these are where the microphones are, and this is how I'm going to be heard on the stream. It's very likely I'm going to end up over there and maybe up and down these steps. So if I start to do that, please start directing me back here. Okay, so I'm here to talk about the rise of the RSE, the Research Software Engineer. If you want to follow along with these slides, by the way, if you just click on, follow my Twitter stream at Walking Randomly, you'll see the links there and so on. So, what is an RSE? RSE stands for Research Software Engineer, and essentially we're the people in research that do computing. So if you think of a continuum where you've got software engineering, sort of like pure software engineering on one side, and pure research on the other, we're the people that exist somewhere in the middle. And I've been talking to lots of people over the last 2 or 3 days, and I think a lot of people in this room identify with exactly this position. You're not quite a software engineer, you're not quite a pure researcher, you're this thing in the middle. And we felt, the UK community felt that it was important to actually recognize that this role exists, because a study by a UK organization called the Software Sustainability Institute demonstrated that actually these people had at one point something like 194 different job titles. When you looked at job adverts that were coming out and you said, that's a research software engineer, that's a research software engineer, and you added them all up, you just had all kinds of titles. And I believe that the reason why this was the case is because there was no real place for what we now call research software engineers in UK academia. So they were shoehorned wherever we could make them fit. That was essentially what happened. It was decided that this wasn't such a good state of affairs. And back in 2012, it's not all that long ago, but it seems like an eternity now, James Hetherington of UCL came up with the title Research Software Engineer at one of the Software Sustainability Institute's collaboration workshops, and the title stuck. And fast forward to a few years later, this was our first Research Software Engineering conference 2 years ago, nearly as big as JuliaCon. The one that's going to be in September is going to have about 320 people, so I feel like we're sort of like playing leapfrog with you guys, you know? Okay, so we're now a big community, and so there's clearly a lot of us, and we're doing pretty well. I could give a talk about the history of the international research software engineering movement, but there are people that do that better than me. Simon Hetrick, who's one of the directors of the Software Sustainability Institute, has got a fantastic talk, and the slides are there, and I encourage you to go and check those out. You'll recognize one or two of them in this presentation. I have blatantly ripped him off for some of these slides. Also, if you want to do some background reading, we wrote last year what we referred to as the State of the Nation report for research software engineering. We wanted to sort of talk about where we came from and why and where we think we're going to and so on. And so I recommend that you look at that link as well. So that's the big picture thing. I'm not very good at big pictures. I'm the kind of person that spends his life in the trenches, figuring out what to do next and figuring out tactically where we can go. And so what I'd like to talk about is what I have been doing for the last 3 years when I was at the University of Sheffield. And I'd like to focus on how you actually build a research software engineering team that can support a university. So for me, the story starts back in 2014 with this guy, Professor Neil Lawrence. He doesn't look it in that picture there, but he's a professor of computer science. He specializes in machine learning, and he had a mission for me. He got in touch with me and he said, "How would you like to ditch your commute and change the world?" Well, at the time, I was living in the city of Sheffield and I was working at Manchester, and I had, it was 4 hours round trip daily commute. That included lots of walking and trains and so on. And round about back then, my Twitter stream looked something like this. It was just an incoherent rant at various train companies. And so I had no idea how we were going to change the world, and I'm not even sure that we've made a huge dent in this situation. But to be perfectly honest with you, he had me at ditch the commute. And so I joined him, I left Manchester and I joined him at Sheffield. So in March of 2015, the Sheffield Research Software Engineering Group consisted of one person, me. I looked younger, I didn't have grey hair, and my remit from Neil, he said, your job is to enhance the University of Sheffield's capacity to produce high quality, efficient and sustainable research software for the entirety of human knowledge in all relevant languages and technologies. And anybody who's read my blog would realize I'm not even that great a programmer. I'm sort of average at best. So added to that, we had some extra problems. I didn't really have any strategy. I mean, that was the sum total, the brief. Come here, do it. So I had no strategy, I had no money, and I had no people. I couldn't hire anybody to actually get any of this done. So I very much felt like this guy, to be perfectly honest. Things were not looking good for me. But then, and my plan at the time was essentially, I was just going to help academics with software. I was going to turn up at Sheffield and say, who needs help with their software? And then some stuff would happen, some more stuff would happen, and I would profit. So that was the plan, such that it is. A couple of years later, we had a fantastic, diverse group, and show some of them here. We were growing so fast that just after I took this photograph, we hired 2 more people. So the group was just growing bigger than I could keep track of. And we were working in a whole range of languages. We were supporting projects in pretty much every area of the university. So to a first approximation, we were managing the entirety of human knowledge. And these guys were all pretty much grant funded. We managed to get them on permanent or long-term contracts. They were supporting the entire university, and we were doing so well that by the time I left, the IT department decided that we should, that this whole endeavor should be underwritten by IT. So we didn't have to worry too much where our next paycheck was coming from. We could offer people permanent contracts. So this was a big change. My task now, I've left Sheffield, is to do all of this again at the University of Leeds, where there's currently no research software engineering group. And this sort of like led me to reflect, how did we do it? How did we go from just one person that didn't really know what he was doing to a successful team that was sustainable and so on? And so that's part of what this talk is about. I'm reflecting on some of the things that I think worked, and then I want to turn to you guys and say, what would you have done? What did I miss? How could I have done this better? And maybe you might want to use these ideas to set up your own research software engineering group. So the first step is pretty straightforward. You need to find someone who needs you, otherwise known as take away their pain. If you want someone to love you and to follow what you're doing, find something that's causing them pain and take it away. And in the world of research, I guarantee you'll find plenty of people with pain in software. Okay. So the Software Sustainability Institute, always sort of the grandfather of all of this, they did some surveys of academics where they said, what percentage of your research is dependent on software? And they came up with these figures here. So 92% of academics said that they use research software. Now let's be clear here, that they meant actually software that was integral to getting the results. They're not talking about Word or LaTeX to write it up and so on. They're talking about computational stuff to actually get the results. 92%. So that's pretty much all of academia, right? I think the 8% who said they don't use research software didn't understand the question. And a huge percentage of them say that their research would simply not be practical without it, and at least half of them develop their own software. Okay, so there's a huge number of people that are doing it. Further studies by the Software Sustainability Institute showed that something like 38% of the total spend on research in the UK was spent on software-reliant research. And this is going up year by year. This is only going to increase. The number of papers that indicated software reliance got up to 65% by 2017. And if you want to check out this data, the links are in the slides somewhere. And you can, it's all on a GitHub repo, so you can find out how all of this was done. And the thing is this software, most of it isn't very good. So I give a talk called Is Your Research Software Correct? With the The answer being, well, as you can expect, almost certainly not. And I put slides up like this to put the fear of God into upcoming PhD students and postgraduates and so on, where I talk about where superb scientists had to retract papers because of really basic mistakes in software. We live in a world where an Excel spreadsheet, an error in an Excel spreadsheet can change the world. Because that Excel spreadsheets are research software for an awful large number of people. And so I've always been talking about, for the majority of my career, I was a research computing support guy. Okay? So in fact, at Manchester, I was the MATLAB guy. If somebody had a MATLAB problem, I worked with them to help fix it. And then I sort of expanded into other languages. And so over my career, I've worked with what Neil Chu Hong of the Software Sustainability Institute refers to here as non-elite scientific software. And behind those headlines that I showed before, such software is slow, it's untested, it's unusable, it's broken, it's incorrect, and worse, it's completely invisible. You know, I think that if you put your code on GitHub, and that's it, you're already in the upper echelons of what most people do in research computing. And in fact, when somebody said, what's my big ambition in life, I just said, get all researchers to use version control, I'm done. I don't need to do anything more advanced than that to be happy in my retirement. Greg Wilson he's the guy behind the Software Carpentry Foundation, the international foundation that teaches researchers the basics of research software. So he teaches them things like version control, maybe you should write a script instead of doing stuff manually, testing is a good idea, perhaps we might want to think about it, that kind of thing. And in a talk that I saw him give, he made this quote, and he said, the gulf between the computing scientific elite and those whose idea of science is emailing spreadsheets to each other is growing, and that's bad. And I think that it's very important that when experts, such as pretty much everybody here, I would categorize as experts, and certainly all of the talks that I've been seeing about how you're using Julia and so on, actually think about the way that the majority of domain scientists are doing science today. It's different, completely different levels that we're working at. To try and show graphically what I mean, I sort of feel that the kind of ideal of a lot of research computing is that to get their results, somebody just pushes their data through some kind of function and the results come out. And it looks like this. It's, they just flick over the first domino and everything just proceeds beautifully. And they use a range of technologies using containerization and cloud computing and all of this great stuff that you see in headlines. In practice, the kind of people that I tend to support, it looks more like this. But then, instead of trying to work out how to make all of the dominoes, how can we change something so that everything will just proceed? What we do is we employ graduate students to manually go and knock over each of the other ones over the next few weeks. And so it was this kind of computational research that I wanted to change. So you can see that I was very much focusing at the low end rather than the high end, which I think the Julia developers and so on are used to. When you actually also look at the way that much of research is funded, in my fellowship proposal, I referred to the long-tail researcher, and that's not a weird-looking dinosaur. It refers to this long tail of grant funding. And so this is from the NSF, and they sort of demonstrated that 80% of all grant awards are very small. Here they're less than $350,000 for, say, 2 or 3 year project. That's enough for like one research assistant, maybe a laptop, definitely no HPC or cloud time. And that one person is going to be expected to do the entire project. They're going to have to be a domain specialist, they're going to have to be an expert in statistics, they're going to have to be an expert in HPC, in programming, and they can't do it. And this is 50% of all of the grant dollars from the NSF. And when you look at similar funding bodies in the UK, for example, you get similar kind of numbers that come out. So there's an awful large number of people that either don't have the time or the expertise to do research computing correctly. And so I think that's why we have many of these problems. And in fact, over my career, when I've spoken to researchers that are like this is what they tell me. I'm under-resourced. I lack training. I don't have time. I've actually had people just say to me, Mike, I am so alone. I wish there was somebody who could help me with this stuff. And so there are a huge number of people that we can support as research software engineers. And so we found our audience. The next thing is what do you do with them? So the first thing is I think that in order to create a successful research software engineering group, you have to do what we've started referring to as FATPU support, free at point of use. Otherwise known as no job is too small, we'll take on pretty much anything, or the first hit is free, so you know what's coming next. Okay, so the kind of work that I mean when I talk about FATPU support can be summarized in this testimonial that was written for me by someone called Felicity Freeman, who's a material scientist at Sheffield, and she had written some, in this case it was MATLAB, she'd written some MATLAB code that it performed her analysis perfectly, but it was just far too slow. She needed to iterate over hundreds of times. She applied for time on the HPC system. She didn't really need it. It took me 2 days to make it 800 times faster. And that's the kind of thing that pretty much anybody in this room could do, I suspect. Because you know, when you have someone whose day job isn't to program, it's pretty straightforward to take it and optimize it. And in fact, I've had lots of stories that lots of discussions over the last couple of days that when I told this story, people said, oh, that's how I got into Julia. I did exactly this. Okay. And then other people that worked in my team, they do things like, this is another MATLAB example. So, you know, you've got a researcher that's got some old MATLAB code with MEX files. They want to use HPC. They've never used an SSH server. They don't know what Bash is or a SunGrid engine scheduler and so on. There's an awful lot of things that you can do to help. Very small interventions. And then we've got more examples. We've got one here where somebody just took some R scripts, turned it into a package for the researcher to increase their research impact and so on. The kind of thing that's very straightforward for a programmer, but the researchers say, well, we don't have time. We need to focus on the papers and so on. And then this is a favorite one of mine where literally a chat over coffee and I saved someone £1,000 a month in their cloud computing time because I told them that spot pricing was a thing. So free at point of use support is absolutely vital for setting up a research software engineering group, but, so it helps you to do all kinds of things. You can organically discover the researchers' needs at your university, helps you build reputation and relationships, lets your team develop themselves in all kinds of areas. You can play with new technologies and so on, and you can provide quick wins. The thing is that it needs institutional buy-in. Somebody at your university or institution has to decide that this kind of support is worth having, and they need to put some money in to pay for the people to come and do it. Okay, so we'll get back on how you get institutional support later. So, the big aim of research software engineering support is to turn FATPU into CATPU, or costed at point of use support. What I mean by this is, you win some grants, either in your own right, or more usually for a research software engineer, you put in the software support for other computational grants, okay? And this is the payoff. And so the big sort of success at Sheffield that enables us to start doing this is that both myself and Paul Richmond won these software engineering fellowships from the Engineering and Physical Sciences Research Council. These were 5-year projects, I'm still in the middle of mine, to focus on how to improve research software. And I think this is an extremely important step forward for funding councils. The EPSRC explicitly targeted weirdos like me who have never published a paper since my PhD. I am not the kind of person that would normally win a fellowship like this. And the funding councils are saying, we recognize this position now. We recognize this idea of research software engineer, and we want to support it. We want to support these people to help go and change the world. And that's an amazing first step because it shows that the funders are actually behind all of this. And then alongside that, we started winning grants in other areas. So here was one where you've got two very serious-looking academics that have just won a fantastic grant and an ecstatic-looking research software engineer that can't quite believe his luck that he's in the same room as these people. The way that I got involved with these guys is they had a problem getting an R package that had been developed by a PhD student to run on the HPC system. I made that problem go away. I had a coffee with them and said, what are you doing? Linear algebra problems. It might be that I've got some ideas on how I can help you. And I've been talking to some people at this conference to how we can help them shift into using Julia, so that would be kind of cool. And then I've got more examples. The idea is you want to make sure that you attach yourself to grants all over the place. So here's another grant in mathematics, we've got one in linguistics, we've got one in neuroscience, and so on and so forth. But this is something that you can do with a pool of research software engineers that you can't do with the traditional research associate model, and that is you can start putting fractional time from a research software engineer into grants. So you can take a project that needs a little bit of computational support, but not enough to support an entire programmer, and say, how would you like it if you actually had somebody come and help you a day a week on your programming, to take care of all of the sort of the design issues and the testing and the documentation that you as scientists perhaps don't have time to do. And we can make sure that you do it better. Would you like that? We would like that very much. And so the idea is then is you can, once you've got this group created, you can start taking advantage of that and you can start becoming income generative for the university. And that changes the way that the university views you as a unit. You're no longer just a cost sink. You're something that's helping bring in the money. The next thing I think you need to do as a research software engineering group is align with the university business, otherwise known as speak their language, or be absolutely everywhere. So one of the ways that we did this is Paul, for example, set up an undergraduate teaching module, teaching GPUs. So he just started teaching the undergraduates and master's students and so on. I partnered with a lecturer in biomedical science, and we started teaching bioinformatics to undergraduates who'd never programmed before. So universities say that their teaching is research-led. So we made sure that they actually did that they were research-led. Sorry, I'm just seeing that I've got 15 minutes left has put me off my stride. That's okay. And we did things like we helped the entire physics department move from using a random collection of programming languages to doing everything in Python and the Jupyter Notebook and so on. I realize that that's not going down well with the Julia audience, but what can you do? And we did things like we worked with a high-performance computing team to improve their documentation and the way that they installed things and so on. We worked with the library to take their data repository and put some sort of visualization front end on it. The thing that I liked about this story is when the library were presenting this to the community at Sheffield for the first time, I was sat in the audience and the guy that was presenting it said, and of course, we did all of this with Research Software Engineering Group. That's right, isn't it, Mike? It's like, yeah. And a member of my team was upset because at the coffee break, she heard somebody from the computer science department saying, those research software engineers, they're like rats. They're absolutely everywhere. To me, though, it's like this is why we're succeeding, because we're absolutely everywhere. It means that all the different aspects of the university business realize that research computing is important to them, not just the HPC department anymore. And that started changing the way that the university was thinking about us. I'm going to skip through this section because we're running out of time. Because this is the thing that I really want to focus on. Something else that you need to do to set up a research software engineering group is really focus on the people within the group. Because, like these guys, we have something of a problem in research computing. And in order to recognize this problem and then do something about it, you first of all have to acknowledge an unfortunate truth. Because you see, this truth will set you free, but first, it will do something else. And that truth can be summed up by this tweet by Wes McKinney. So Wes McKinney's the pandas guy, right? Everybody knows him. And he said this: one of the major reasons I dropped out of my PhD was because I didn't believe academia could properly value software contributions. And if Wes McKinney felt this way, how could a guy like me that just fixes up scripts make a career in research computing? It was going to be very difficult. Gary McIndoe was somebody that worked for the Research Software Engineering Group at UCL, one of the, I think, the first research software engineering group. And he said this: it takes bravery to actively choose to be a research software engineer instead of an academic. Because Maybe this is all a fad. Maybe it's all going to run out. We don't know yet. There's no career structure in universities that recognizes what this is. And this always leads to me having what I refer to as the talk. When anybody joins my team, as a research software engineer, I sit them down and I say, you are aware that you might be about to ruin your research career because you've just finished your PhD. Working for me, you will have no papers. It's going to change the way you're going to be viewed. So they need to be okay with that. So these are some of the problems in RSE. There's no career pathway within universities. It's not recognized by human resources departments as a thing. You're either an academic or you work in professional support services. But we're this thing in the middle. We're something in the middle, and that's not recognized yet. There aren't many research software engineering groups in the country. So if you start having a career in one and you want to move to another university, you'll get there and say, is there any jobs for research software engineers? And that university will say, for who? For what? And that's not a good position to be in. And there's a lack of recognition within academia for software itself. So there's these headlines here, for example. REF is the Research Excellence Framework. It's how the UK assesses its research quality. Universities want to get good scores in REF because it's proportional to the amount of research funding that they get. 3% of the REF 2014 case studies mention software. They're focused on the papers. That's all that anybody's interested in. And the quality of the code is really poor, which means that anybody that wants to commercialize it, the academics aren't interested in sharing the code. So there's all kinds of problems in how software is viewed within academia. So what we could do as a community is accept it. This is how things are. People have said to me and to other colleagues in the research software engineering community, you've got some nice ideas, but they'll never catch on. You should just accept it and do the best you can. And this is what I have to say about that. It's not something that I'm going to that we agree with. The reason why this community exists is because people refused to accept that this was a situation. We said, we're going to change the way things are. And things are getting better all of the time in research software engineering. So the Software Sustainability Institute enjoys funding from multiple funding councils now, not just the EPSRC, but several other funding councils in the UK. So it shows support in all kinds of different subjects, not just the traditional ones that we associate with research computing. For example, the BBSRC, that's biology essentially, recently directly started saying in some of their grants, we recommend that you include research software engineering time in this grant. Absolutely fantastic, because all of a sudden researchers that never heard of it are saying, do we have those? Do we have any of those in our institution? Like, yeah, hi, here I am. And you get included. Research software engineering groups are turning up all over the country. This is out of date. There are a lot more dots on this graph now. And we have an association of research software engineers. So, which has got the, this is the people that put on the conference that's happening in September that I showed you on an earlier slide. It's got something like 700 members. It's growing all the time, and it's fantastic. And the EPSRC was so happy with the first tranche of fellowships like mine that they did a second tranche. So there are now the idea of having research software engineers that have got academic fellowships, or things that look like academic fellowships. I refuse to call my fellowship an academic one. But there are more of them, and there are rumors that other funding councils are going to follow suit. So research software engineers are very much agents of change in the way that software is being viewed in academia. I'm going to have to skip through this just for time reasons. The next thing that I think you need to focus on when you're building a research software engineering group is diversity. Otherwise known as monocultures should be considered harmful. The first thing is you should have diversity in people. The research software engineering community as a whole is atrocious at diversity. It's pretty much all white middle-class males. That's it. There's a very small percentage of women, and for other minorities, the percentage just plummets. It's atrocious. It's embarrassing. We need to do better. I'm not quite sure what we did right at Sheffield. We had a very nice balance, but we weren't perfect. After that photograph was taken, we did an advert for a high-performance computing specialist, had 0 female applicants, and I didn't know why. because I didn't know what we were doing right earlier on. So I reached out to the community and said, here's our job advert, what was wrong with it? And oh boy, were the things wrong with it. So we can do better. And indeed, you can help foster improved diversity by actually just making sure that you train people in various areas. So we have Tanya Allard there, who until very recently worked for me, who was working with Code First Girls to get more women interested in coding, teaching them how to use Python, and I guess we should focus on Julia. So doing all this kind of work. But also, we need a diversity in technology. So I put this slide up to show some of the stuff that we'd worked on in the last 12 months. These were some of the languages and hardware platforms and so on that we've worked with. And I refuse to do what a lot of corporate IT departments want to do, which is, we should standardize on this technology or that technology. No. We need to, in order to support the academic community, we need to support a whole range of technologies to enable exploration, to make sure that we're not betting on the wrong horse, because the odds are, if we say, oh, we're going to fully go behind that technology, then you guarantee it'll be the one that will fail and all of the others will succeed. So what's next for research software engineering? That's how I built up my group. It's the kind of principles that I hope to use when I'm building up the group in Leeds. And for the community as a whole, I think that what we need to continue to focus on is improved recognition for the role. We need to definitely improve the career structure. So I want to make sure that there'll be a job title at the University of Leeds, for example, that will be research software engineer, right from intern right up to the equivalent professorship. I want to have that career pathway in existence. That's what we need to do. And this will help engender a growth in the number of software experts that can help academics improve research software, because we will get the research software that we deserve. And the only way that we can get better software is to support the people who write it better. Thank you. And then also through things like training and outreach, and by working alongside our academic colleagues, we can make sure that we have give our academic colleagues greater access to skills researchers. And also, what next for research software engineering? You are the future of all of this. If I do my job correctly, and if people of my generation do their job correctly, you'll not have to fight for your place in academia the way that we did. It'll just be there, and you'll be able to apply for these jobs straight out of PhD, and then rise up through the ranks and produce great software. So thank you for listening.
And it's on.
Do we have questions for the speaker? From here.
Have you thought about focusing this entirely on software engineering or combining it with other generic scientific support services, data analysis, statistical consulting, data visualization, that sort of thing? Does that make it easier or more difficult to sell what you want to do?
It makes it easier to sell. So absolutely. Over time, we want to have like a full suite of support experts that can do, for example, machine learning. I'd like to have people that have got enough machine learning expertise to be able to advise when should you use deep learning and when is logistic regression good enough, and so on. So yeah, absolutely start to expand out into those other support areas that are related to software.
So when you solicited feedback about why you didn't have any female applicants for that HPC position that you had advertised, did you learn anything useful?
Yes, so what I'll do is after this talk, I will retweet the discussion that came out of that. It was things like some of the language that we were using. We had far too many essential things. We said an RSC must be this, and this, and this, and this, and this. And apparently there's been research that's shown that men will look down that list and say, I've got 3 of those 20 items, I'll apply anyway. Because we wing it. Whereas women will say, oh, that's clearly not for me, I don't have all of it. That's apparently what some of the research says. So they were saying you need to think long and hard about what really is essential and keep to that. Things like that can help. And so I'm about to, at Leeds, we're about to hire a new HPC specialist research software engineer, and I'm talking with, on Twitter, they're women in HPC, and I'm letting them look at the job description and saying, can you help us make sure that we're doing better before we advertise this time? Yeah.
Do you need a PhD to be an RSC?
No, but it helps. I think what you need, first of all, you need many of the skills that you will have learned. Sorry, who am I talking to? I can't see. There you are. So you need many of the skills that you would learn during your PhD, but getting a PhD is not the only route to getting those skills. So, for example, when people say, what's the difference between a standard software engineer and a research software engineer? To a first approximation, my answer is advanced mathematics. You need to know lots about linear algebra, Fourier transforms, and floating point arithmetic, and which you're more likely to have if you've got a PhD. But more importantly for me, it's to actually have some kind of empathy with the researchers that you're working with. A lot of people will say, when they work in sort of more traditional IT, why do researchers behave this way, or why do they behave that way? Are they doing it just to wind us up? When you've worked in research, you actually understand those behaviors, you empathize with it, and you work hard to, help them with their problems. So I don't think it's absolutely necessary, but it really does help. Yeah.
Mike, you made someone made a remark about likening RSCs to rats. But you're people who go in for hire into research groups. Do you see yourselves more like Wild West gunslingers or Japanese Ronin?
I see us more like we're carers, we're nurses, we're doctors, we're the code doctor. That's what we are. Yeah. I'd like us to sort of be well integrated in sort of all aspects of research computing, whether it be teaching, data management, research, and so on. So yeah, but just to help out, I mean, the whole aim is to make better research, right? So through better software.
Yeah, so I have a question about, right here, yeah. So, I mean, I'm looking to do like a lot of software with my academic career, and I think that we have the similar problem that for some reason academia does not value software. So I'm wondering if you have any incentive ideas, like any ideas that you'd like to push to funding agencies, grant agencies, like here's the right way to evaluate software such that, globally it could become something that's more part of the academic resume or academic currency.
Yeah. So, not really. I'm kind of looking at the community to say, what should we be doing? One thing that I think is fairly obvious is that we should always be citing our software better. And there should be ways of publishing it so that they're part of the academic record. And indeed, there do exist ways. It's very straightforward to get a DOI for your software via GitHub and Zenodo and so on, and then to make it part of the scholarly record, and then actually cite the software that you're using. And what I find fascinating about all of this, though, is that there's a paper called Software Citation Guidelines that was published like 2 years ago, I think. So that makes you think, wow, citing your software is bleeding edge research. It's like, isn't that insane? Yeah, so I think things like that, but also funding bodies that are starting to recognize the need for research software engineers. They've just had lots of conversations with people like me who have said, you really need to do this, you really need to do this. And slowly but surely it's actually happening. So I get, as a research software engineer now, I'm sometimes asked to be part of the review process for funding proposals. So yeah, it's happening. But any suggestions that anybody has, more than willing to, please give them. Yeah.
unfortunately, we've run out of time for questions. Let's thank the speaker once more.